So, now we will do position time graph for uniform motion. So, see here now, position time graph for a uniform motion. Now, see here, if you have taken like this is your x axis and t is here time, this is origin. If you draw the graph between x and t, it means write down the value of x for the different time intervals. So, you will be getting graph like this. It means this straight line graph shows here the motion is uniform. So, if the body is moving with the uniform speed or with the uniform velocity in a straight line, then we can draw the graph like this. So, this is a position time graph for uniform motion. Here if you take time, two time intervals, suppose this is t1 and this is t2, this is x1 and this is x2. This point is A, this is B and this is C. This will be representing delta x and this is delta t. So, you can write here BC is equal to delta x is equal to x2 minus x1. Now, AC is equal to delta t is equal to t2 minus t1. So, if you write here this is average velocity is equal to x2 minus x1 upon t2 minus t1. So, we can also write delta x upon delta t, but instantaneous velocity v is equal to, you can write limit delta t tends to 0, delta x upon delta t is equal to dx upon dt. So, here if you want to calculate this one, but see here whether you calculate this portion, whether you calculate directly this, here velocity will remain same. So, if the motion is uniform, so instantaneous velocity and average velocity will remain same. So, here we take here theta. So, now we can write this slope of xt graph v is equal to delta x upon delta t is equal to tan theta. So, this tan theta basically tells slope. So, whether you take this angle theta or take here theta, this theta remains same, therefore, also the speed remains same. So, just by guessing theta you can tell the which graph or the which body has greater speed. For example, if you are taking two graphs like this, one is here t and this there is x. I have taken two graphs A and B. Both graphs are for the uniform motion. Out of these two graphs, which one has got greater velocity? Just to see here, this is theta 1, this is theta 2. So, as you know it, slope of xt graph is equal to tan theta. Here we are seeing here theta 2 is greater than theta 1. Therefore, here also Vb is greater than Va. So, you can guess the velocity or you can calculate also the ratio of these two velocities if angles are given to you, or you can tell which object is moving with the greater speed. Now, if you take like this graph, just guess it, what is this? If you have got x like this is your t, like this is your this, and this is x naught, and graph is going like this in a straight line. What type of motion is represented by this? So, if you observe this graph, you will find x naught is initial position at the origin at the time 0, but after that its position does not change with the time. It means this body remains stationary. So, when the body is at rest, the graph is like this, and if you calculate slope, slope will be equal to 0. That means velocity is 0.